Good day, grade 12s. In this video, we'll be taking a look at some more calculus part 3 specifically. And in this paper or video, we'll be taking a look at some of the optimization theory. Now, essentially what these types of questions are normally asking to find the minimum or maximum of a certain value or a certain situation, so that we can best make use of the resources we have. Now, normally this will include you having to find some kind of function that represents the situation, then using the first derivative to find minimums or maximums, and then from there find the actual values. Now, again, this is part of your differential calculus, which is about 35 over 150 marks. And we will be working through the June 2022 question number 9, which follows on optimization theory. Now, in this question, they ask to tell you that in the figure below, triangle ABCE has a base of x meters. So essentially, BE, which is the base of the triangle, is x meters. And they also tell you that the base and the perpendicular height of the triangle has to add up to 10 meters. So in this case, they've already made or given the perpendicular height a symbol, which is h. So we know that x plus h must equal to 10 meters. Now the triangle is mounted on the rectangle BCDE, which has the perimeter of 32 meters. So again, remember, since it's a rectangle, opposite sides are equal. So that means BC will have to be equal to ED and BE has to be equal to CD. So that, in a sense, we know that BE plus ED plus CD plus BC should be equal to 32 meters because it's the perimeter. Now, for the first question, I ask us, okay, show that the area of figure ABCDE is equal to minus 3 over 2x squared plus 21x. So if you take a look at, they're essentially asking you for the area of this entire shape. So it consists out of the triangle and rectangle. So we know that adding the areas of these two shapes will give you the area of the entire shape. So let's start by first trying to find a way to calculate the area of the triangle. So we know that the area of a triangle, specifically ABE, will be equal to a half your perpendicular height times your base, which in this case your perpendicular height is h and your base is x. So we can say a half of h times x. But now if we take a look at this formula they want us to prove, there's no h's involved there. So we need to try and get rid of this h. Now luckily for us, they told us that x plus h is equal to 10. So using this, we can then say, but h is then just going to be 10 minus x. So then I can take this answer I have and I can substitute it back into the area of triangle ABE to get rid of the h and just have x's in there. So therefore, we can say the area of triangle ABE would then be equal to a half of 10 minus x times x. Now if we simplify that a little bit, that's going to give me a half x. Now it's going to give me 5x minus a half x squared, because I take the half and the x and I multiply it in. So a half times 10 gives me 5, and that 5 times x gives me 5x, and then a half times minus x gives me minus a half x, times with x gives me minus a half x squared. So now we have the area for the triangle. Now next up, we need to find the area for the rectangle BCDE, and in this case the area is normally just your length times your width, or or your height, yeah, times your width. Now in this case, we already know that the length is x, but we don't know what the width is. So we can say, okay, well, we know that the circumference has to be equal to 32. So we know that the circumference is going to be 2x because it's base times base. Not base times base, apologies. It's going to be your length times plus length. So the circumference is equal to your base times base, so which is BE plus CD plus BC, which is your two widths, plus ED. Now in this case, we know that BE and CD will be equal, so that's going to be x plus x. And BC and ED are also going to be equal, and that's just going to be my width plus my width. And then I know this circumference in total needs to be equal to 32 centimeters. So from there I can then simplify a little bit. Then we have 32 equals to 2x plus 2w. And now again, if we take a look at our formula, we only want x's involved in there. So we can use this equation like we did the x plus h equals to 10 to get rid of the width. So we can now solve for w. So it's 32 minus 2x equals to 2w. Therefore, w is just going to be equal to 16 minus x. And now we can substitute that into the area of the rectangle BCDE, which would then be equal to the length. The length in this case is just x. And then your width, we just calculated, would be 16 minus x. If we simplify that a little bit, we'll have 16x minus x squared. And from there, we can now say, therefore, the area of A, B, C, D, E is just equal of the area of the triangle A, B, E plus the area of rectangle B, C, D, E, which then gives me 5x minus half x squared plus 16x minus x squared. And if I simplify that, it gives me minus 3 over 2x squared plus 21x, which is what we wanted to prove initially. So in this case, we rewrote all the variables we could have in terms of x, and then we substituted that into our area formulas, and then just combined the two to find the area formula for the entire shape. Now, the next question then asks you, okay, determine the value of x for which A, B, C, D, E has a maximum area. So in this case, I am going to say, okay, but the area of A, B, C, D, E can be represented by the function minus 3 over 2x squared plus 21x. And remember when I said, when I started this video, a function attains the maximum or a minimum where the first derivative is equal to 0. So therefore we can say, therefore we equal the first derivative to 0. The first derivative would then just be minus 3x plus 21 equals to 0. And if we solve for x, we start by throwing the 21 over, so it becomes minus 21. Divide on both sides with a negative 3. And then we'll have that x is equal to 7. So this function will obtain a maximum where x is equal to 7. Remember, you find a minimum or a maximum point by equaling your first derivative to 0. Okay. And now 9.3 just asks you, okay, Hence, determine the maximum area of A, B, C, D, E. So we can now say, okay, but the area will be at a maximum where my x value is 7. So that gives me that minus 3 over 2 times 7 squared plus 21 times 7 will be where there's a maximum area, which would just be 73.5 squared meters. And then that is that for optimization. Now remember, take this following advice from a little honeybee. Create a buzz, sip life's sweet moments, mind your own beeswax, work together and always find your way home, and stick close to your honey and remember to always be yourself.